Alright, so once again, warm-up number 74 is the same as what we started with yesterday. Look at number 1, make an input-output table with domain -3, 3. Does that notation seem familiar? Yes? Very good. It's interval notation. Yeah, bringing it back. Oh, yes. For f of x equals 1 over x, plot the points. Number 2, graph f of x equals x cubed, then transform according to g of x equals negative f of x minus 4 minus 3. Number 3, factor. Part A is 3x cubed plus 9x squared minus 2x minus 6. Part B, 3x squared plus 5x plus 2. And number 4, divide the polynomial with synthetic division. 5x cubed minus 3x plus 15 divided by x minus 1. And number 5, solve the quadratic equation y equals x squared minus 2x minus 24. Like I said, by now you should be able to do all of them since I went over them yesterday. See how you do? Should be about, should be starting number 3. It's not number 4 by now, yeah? Alright, give you some more. Alright, here we go. Number 1. So, before I graph it, we need a table, yeah? You guys are funny. Alright, so our table from, what did you use for the domain, Ivan? Read it to me. Very good, negative 3. Negative 2. Negative 1. Yes. 1, 2, and 3. Yes. That's what the interval means from negative 3 to 3, and it includes negative 3 and 3. Those are the brackets. Yes? You guys remember those? Yes? Yeah, we're bringing it back. Alright, and once again, if I use f of x, 1 over x, instead of that I use parentheses, I'm just going to show you the work for the first one, negative 3. So this is f of negative 3 equals, what is 1 divided by negative 3? Well, negative 1/3. Goes right third. Yes? Yeah. Alright, so then f of, the rest we're just going to do in our noodles. We can go a little bit faster. If I substitute negative 2 here, that's negative 1/2, yes? 1 divided by negative 1 is negative 1. What about 0? Tell you never what you wrote for 0. Yes, undefined. Undefined. If they wrote 0, slap them by now. My goodness. Alright, then 1 over 1 is 1. 1 over 2 is 1/2. And 1 over 3 is 1/3. Alright, let's plot that. We got negative 1, negative 2, 1, 2, negative 1, negative 2, 1, 2, negative 1. It sounds like a song. Let's go. Negative 3. Oh, I guess I need to go one more. Negative 3. Okay, I think I know what I'm going to do. Wow. Oh my goodness. Did you guys see what it did? Fine. My goodness. Yeah, very funny graph. Alright, so I'll just add negative 3 right there, positive 3 over here. Alright, there it is. Okay, so here we go. Negative 3 and negative 1/3. Negative 3, negative 1/3. Negative 2, negative 1/2. Negative 1, negative 1. 0 is undefined. 1, 1. 2 and 1/2. 3 and 1/3. Curve it, please. It's not a straight line. It's a curve. Curve. Yeah? Okay. Alright. Let's go to number 2. Number 2. So, parent function, what 2 points do we go through? Tell your neighbor, please. Yeah, by now, if they don't say 0, 0, and 1, 1, oh my goodness. 0, 0, and 1, 1, obviously. Yes. And just for the sake of it, they're also going to go through -1, -1. But for right now, if you get these two, that's fine. So here's my parent function. All right, there it is. Before I move it, 4 to the right and 3 down, which was yesterday's, yes? Tell your neighbor what this negative is going to do to the whole thing. It's going to invert it, yes? Or reflect it about the x-axis. So that means this point, instead of being at 1, 1, where's it going to be at? 1, -1. Yes? So that means this is going to look like this. That's why we need that extra point so that we can move it around with some of the stretches or transformations. Yes? All right, and now we can move it 4 to the right, 3 down. So we go 4 to the right, 3 down. So there's our new vertex, and this little point is right there. So there it is. Let's go. Is that what you guys got? Good? Yeah. All right, good. Let's go to number 3. Number 3. Once again, tell your neighbor what your factors are for number 3A and 3B. So we can just go through those. All right, factors for 3A. How about, who got when we called on our what? Caesar, factors of 3A. 3x squared minus 2. X plus 3. Hands if you got that. Looks about right. Pass the one, Caesar. Pedro, what'd you get for 3B? X plus 1, 3x plus 2. Hands if you got that. Looks about right. Let me go over number 4 because your home play had one that looks something like that. And hopefully, with all the practice that we did, you caught it. It goes number 10 or number 12. So here we go. Is this in standard form? Let's find out. Third degree, first degree, 0 degree, it is. But is there a degree missing? Yeah, the second degree. So I'm going to make a box and fill that space once I get started with my synthetic division. On your home plate, when you did the division, you should have accommodated for the missing degrees. If you didn't, oh my goodness. Anyways, and this one is in a standard form, yes, equal to 0, so x equals 1, so we just start with that. So we got 5. We don't have a second degree, so we put 0, -3, and 15. I'm going to go a little bit faster since we're experts at this by now. 5, 5, 5, 2, 2, 17. So my polynomial left is 5x squared plus 5x plus 2 with a remainder of 17 over x minus 1. Hands if you got that. Some of us, yes. Some of you forgot, so make sure you check your stuff because tonight you're going to be doing some more of this. Yeah, let's go. Yay. My goodness. Glass people problems and math. Does it fog out for some of you? Yeah? Well, some of you that don't talk a lot, well, maybe not. But me, I talk a lot, and it's like... Anyways. All right, here we go. Set it equal to 0. X squared minus 2x minus 24. Factors of -24 that add up to -2. Are they? -6 and 4. So my factors are x minus 6, x plus 4. All that equal to 0. Set each one equal to 0. X minus 6 equal to 0. X plus 4 equal to 0 and solve. Plus 6 plus 6. X equals 6. Minus 4 minus 4. X equals -4. Tell your neighbor what these are called. Yeah, I made that big enough, hopefully, so you can remember. They're called zeros. They're called zeros. Oh my goodness. Tell your neighbor why they are called zeros. Yeah, because when we substitute any of those numbers in here, into here or here, at the end we end up with y equal to 0. That's why they're called zeros. However, don't forget this part. They're called what? X-intercepts. Because today we're moving on to graphing. Let's go! Let's go! One of my favorite parts. All right. So, last night's home play, our agenda for today, warm-up number 74, polynomial equations and zeros. Tonight's home play is pages 348 and 349. Odds only. Last night was evens. But tonight I want also the graphs included. Oh yes. And reminder, tutoring after school, be there or be elsewhere, okay? Once again, this is exactly as yesterday's agenda. You just put odds and graph. Yes, make sure you put graph because you need to graph them. So today we're going to be elaborating on graphs. All right. Asynchronous code. No asynchronous code since it's continuing on from yesterday. Once again, last night's home play was 348, 349, evens only. Take a picture, turn that in right now. I'll give you about a minute. So it's due at 9:55 a.m. Once again, your home play for tonight, 348, 349, odds and graphs only. Okay? Get a Cornell note ready, please. You don't need a fair amount. We're going to go expeditiously today through today's session. Copy that. Do it. All right, here we go. Our objective for today: I can identify rational zeros of polynomial equations. I can identify rational zeros of polynomial equations. I can identify rational zeros of polynomial equations. Are we on the same concept? Yes, polynomial equations. Do we need to fill out the fair amount? Oh, no. By now we should know that they are two variable equations made up of polynomials. There they are. Non-examples, hashtags. We got that. From there we talked about zeros and rational zeros, yes? We talked about the theorem. The theorem was that you get the constant, leading coefficient, make a fraction, get all the factors of that, and start trying to find your zeros from there. We did example 1. We did example 1Q. And we could do this one, but for right now, just tell you here, what would be the fraction that you would make for this one, please? What would be the fraction for that one? All right, Chantal, what would be our fraction? Negative 21 over 1, yes? And then we find the factors of 21 and so on and so forth, okay? Copy this table, please, really quick. Title it Polynomial Functions. The first column reads parent function. You got 1, 2, 3, 4 boxes below that. Then on the middle column it says graph, create some coordinate planes. On the next column it says beginning quadrant. And then the last column it says end quadrant. Copy that, I'll give you some time. Copy and... All right. So far, this school year I said we've been working with 3 parent functions. The first one, f of x equals x, copy that. The second one, f of x equals x to the second power. The third one, f of x, x to the third power. Is that correct? And that's been our bread and butter all year. That's what we've been using for transformations. And I just want to make sure we got this solid up to now. Because we're about to embark in the graphing portion of the school year where everything's like graphing galore. But you need to be able to graph it a lot faster than what we've been doing. So hopefully this little table helps you out. Here it goes. This is my table that I made up for you guys, yes? Did you guys know also the polynomial when we did polynomials with the name according to degree and name according to term? My creation, let's go. Anyways, all right, here we go. How does this graph look like? F of x equals x. We know it goes through where? 0, 0, and 1, 1, so it's a straight line through there. All right, so let's do that. That's what it looks like. Okay. How about the parent function of x squared? It also goes through where? 0, 0, and 1, 1. And my parabola looks like that. Graph that, please. And of course, like our warm-up cubic function, also parent function goes through what? 0, 0, and 1, 1. Okay, so it looks like this. Okay. Man, I know it was like anything but a backpack, but what are they dragging? My goodness. A trash can. All right. So look up really quick. Writing utensils down. I'm going to show you a couple of things before I move on. First of all, we know that each part of the coordinate plane, each section, is known as a quadrant. And we start on this side. This is quadrant 1. Don't write this down, just pay attention. This is quadrant 2. This section is quadrant 3. And this section is quadrant 4. Everybody agree with that, yes? We covered this since elementary. Okay, we got it. Okay. So I'm going to do a couple of observations to see if you see what I see without saying anything, yeah? Okay. All right. So, the graph of this one, from left to right. You're like, okay, Mr. Q. The graph of this one, from left to right. Okay. Graph of this one from left to right. Okay? So here goes the outro. You're like, so, here it goes. Pay attention, please. Thinking caps on. Okay. Hold on. Talk to the neighbor, see if they see what I saw. All right, let's see. Let's see if you saw it. If I was to do this, look up. Tell your neighbor, according to this degree, where does it start and where does it end? Yes, quadrant 3, and that is in quadrant 1, which means if I gave you f of x equals x to the 6, tell your neighbor where it starts and where it ends. 2 and 1, yes. Let's put that in general terms. Let's generalize the idea. If a parent function, or if a polynomial function, let me call it that, if a polynomial function has a degree of what? Of odds, it starts at quadrant 3 and ends in 1. If a polynomial function starts with a what degree? Even degree, it starts where? Second degree and ends in first degree. So make a note for yourself for that, because we're going to do that today. We're going to use this today. Use this today. All right. And so on and so forth. Okay? So, now that we have that idea solid, to get any questions? Are we good up to right there? Yes. All right, here we go. So, if I was to give you this polynomial function, look up, you know what to do with that, yes? Okay, so let's do this one together. We're going to do the whole thing, including the graph. So copy that one, please. Example 1 mega cube. Hurry up, hurry up, hurry up. H of x equals x cubed plus 8x squared plus 17x plus 10. Now, if you did your home play, this should go a lot faster since we already know all the process, yes? Up to the graphing portion. Here we go. So tell your neighbor the fraction you're going to create with that and the factors of whatever you have. All right, let's see. Fraction. Who went last? Pick someone. Isaiah, go. 10 over 1, the constant over the leading coefficient, yes. What are the factors of 10? 1, 2, 5, and 10, yes. And all those plus or minus, yes? All right, so let's begin. I'm going to use blue for the positive 1. And my coefficients here are 1, 8, 17, 10. 1 times 1 is 1, combined that's 9. 1 times 9 is 9, combined that's 26. 1 times 26 is 26, combined that's 36. That's not our 0. Now we're going to negative 1. Negative 1. Negative 1 times 1 is negative 1, combined that's 7. Negative 1 times 7 is negative 7, combined that's 10. Negative 1 times 10 is negative 10, combined that's our 0. Okay. So, let's write this out. H of x. Isaiah, pass someone? Ivan, what's our remaining polynomial here? X squared plus 7x plus 10. That is correct. And how do we write this right here, Ivan? X plus 1. Yes. Okay. So far so good, yes? But we didn't stop there, did we? No. So therefore, 10 on top, 7 on the bottom. Factors of 10 that add up to 7? 2 and 5. So my factors are x plus 2, x plus 5, bring down the x plus 1, and all that equal to what? H of x. And that was your home plate. But we're not done now. For tonight, I want this solved. So what do we do, Mr. Q? Change this to what? 0 equals x plus 2, x plus 5, x plus 1. What do we do next? Pass someone, who in last? Ivan. Hector, what do we do?
We do x plus 2 equals 0.
X plus 2 equal to 0.
X plus 5 equals 0.
X plus 5 equal to 0, and x plus 1 equal to 0, and let's solve. Yes. So therefore, negative 2, x equals negative 2, negative 5, x equals negative 5, negative 1, x equals negative 1. Okay? Let's write the names of the solutions. So yeah, we're done because we finished solving. What else are they called? X-intercepts, okay. They're also called roots. And yesterday we used what? Zeros, okay. So pay attention because now we're going to need this term right here. X-intercepts, because we need to graph this. So on the side I want you to create a little coordinate plane. We're going to graph a polynomial function. Alright. So before we graph this, I want to predict where it starts and where it ends. Let's go to the original function. Look up. What would be the highest degree of this polynomial? Tell your neighbor, please. Highest degree. Highest degree, everyone? 3. So what would be the parent function of this whole thing? F of x equals what? X cubed. So where do we start? Third quadrant, which is over here, and where does it end? First. So that means I'm going to put an arrow pointing downward this way, because that's where it starts, and it's going to end somewhere over here. Is that correct? Okay. So now all we need is in-between stuff, yes? So let's guess what? Let's plot our x-intercepts. X equals negative 2 is about right there. What else? X equals negative 5, which is over here. And x equals negative 1, which is about right there. Let me move these over a little bit. Something like that? Yeah? All right, so here we go, from left to right. There it is. And that's our graph. Does that make sense? It starts over here, it ends over there, and in between we have how many roots or how many x-intercepts? 3, okay? Now let me just top it off with a little cherry on top. Look up. What's our constant? So guess what our y-intercept is? 10, yes. Let's go. We good, yes? All right, let's do another one. So let's crank it up a little bit, yeah? Oh yeah, here we go. Copy this one, too easy. This one, example number 2. We got f of x equals x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24. And make some room because we're going to need some room for this one, yeah? Oh yes. All right. So, what would be our fraction for this one, everyone? Tell your neighbor, please. 24 over 1. Yes, 24, which is our constant, and leading coefficient of 1. So factors of that, plus, minus. Let's see, 1 times 24, 2 times 12, 3 times 8, 4 times 6. And that's it, right? All right, so let's get to work. Let's start with positive 1. Positive 1. We got 1, negative 4, negative 7, 22, 24. 1 times 1 is 1, combined, that's negative 3. 1 times negative 3 is negative 10 combined. 1 times negative 10, that's 12. 1 times 12 is 12, and that is 36. Nope, that's not our 0. Next one, negative 1. Negative 1. 1, negative 4, negative 7, 22, 24. Alright, let's see. Negative 1 times 1 is negative 1, combined, that's negative 5. Negative 1 times negative 5 is 5, combined, that's negative 2. Negative 1 times negative 2 is 2, combined, that's 24. Negative 1 times 24, that's negative 24, and guess what? That's our 0. Okay, so look up though. Look up, look up, look up, look up. Check this out. We started with an x to the 4th, so what do we have now? X to the 3rd minus 5x squared minus 2 plus 2x plus 24. Wait a minute, didn't we do these yesterday? Okay, hold on. Some of you are it's not registering. Who can give me the polynomial for that first? X plus 1, yes? We got our first 0, there it is. But we still need to factor this. What do? We already finished positive 1, negative 1, yes? And we still have all this. Well, what do? Positive 2, yes? And now my coefficients are what? 1, negative 5, negative 2, 24. Does everybody see what we're doing?
Yeah.
All right. 2 times 1 is 2, combined, that's negative 3. 2 times negative 3 is negative 6, combined, that's negative 8. 2 times negative 8 is negative 16, combined, that's 8. That's not our 0. You guys following, Connor? Sir? Yeah? Okay, good. All right. Next one, negative 2. Negative 2 times 1 is negative 2, combined, that's negative 7. Negative 2 times negative 7 is 14, combined, that's 12. Negative 2 times 12, that's negative 24. And guess what? That's our other 0. Who can give me this one as a polynomial? X plus 2, yes. Okay. However, what do we have left here, Ivan? Let me go back. We started with x to the 4th. We did the division, we found our 0, and we ended up with what? X to the 3rd. We did again more division, so we're left with what?
X squared minus 7x plus 4.
That is correct, with an x squared. Are we done? Tell your neighbor what to do with this, please. 12, negative 7. What factors of 12 add up to negative 7? Negative what? Negative 3, negative 4. So my factors are x minus 3, x minus 4. Bring down the other factors, x plus 1, x plus 2, and all that equal to f of x. Are we done? No, let's solve. What do we do to solve? Tell your neighbor, please. Change f of x to what? 0. Continue, Jerry. What do I do next? Yeah, set each of those equal to 0. Let's solve. Plus 3 plus 3. X equals 3. plus 4 plus 4, x equals 4, minus 1, x equals negative 1, minus 2, x equals negative 2. These are my solutions. X-intercepts, roots, zeros. Okay. Are we ready to graph? Yes, Mr. Q, our favorite. All right, good. All right, so then let me make some room over here. I want to leave the work there so that you guys can see it. All right, so before I get started with my graphing, look at the original polynomial function. What is the highest degree? Tell your neighbor. 4. Everyone, the highest degree is what? 4. So possible parent function is f of x equals x to the 4th, yes? So where am I going to start and where do I end? Second quadrant, and I end in the first quadrant. So that means I have an arrow somewhere over here and an arrow somewhere over here. All right, and now we just need the x-intercepts, yes? Here we go. X equals 3. 1, 2, 3. There it is. That's 1. X equals 4. 4. X equals negative 1. Negative 1. X equals negative 2. All right, from left to right, let's start over here with the arrow. Go down through this one, back up through this one, back down through this one, back up through this one, and we are done. Woo! Let's go! Let's go. Students, home play, students. That's exactly what you're going to do tonight for odds. Once again, make sure for these, look up guys, look up before you leave. For these, with the cubic, we know that after we find the 0, all we have to do is do the factoring portion and we're done because we're in a quadratic. However, these with a 4th degree, we do our first one, find the 0, but then we end up with a cubic. That means we need to continue going with a synthetic division until we end up with a quadratic. All right? And then the graphing, by now we should know exactly where to start and where to end. Yes? I'll stop right there. Once again, reminder, tutoring after school, be there or be elsewhere. Also, every day, in case you're absent for an extended period of time, we go live at what? 1:30 on Zoom. All right? Talk to you guys later. Peace.